Assignment 2.2, Part 2. Our hypothesis. For cardiovascular response to steady-state exercise, we predicted that the heart rate will plateau after 3 minutes of steady-state exercise. The respiratory response to steady-state exercise, we predicted that the breathing rate will also plateau after 3 minutes of steady-state exercise. Energy system's response to steady-state exercise, we predicted that the main energy system used will be the aerobic energy system. There are 3 different types of hypotheses. The null hypothesis is a hypothesis where there isn't a big difference between specified populations. A two-tailed hypothesis is when it predicts one outcome so that the results can go into 2 different directions. A single-tailed hypothesis predicts the direction that the results will go in. Our method for the experiment. First, we were going to attach the heart rate monitor to our client. We were then going to be measuring the heart rate, breathing rate, blood lactate levels, and O2 saturation levels of the participant before they started exercise. To take the heart rate, we were going to use the heart rate monitor. To measure breathing rate, we're going to observe their chest movements, count their breaths for 30 seconds, then double it. To measure blood lactase levels, we were going to prick their finger and use a lactase monitor. And lastly, for oxygen saturation, we were going to use the saturation monitor. Before the exercise starts, we were going to get our client to warm up on the bikes for 5 minutes. This will help to warm up the muscles that they will be using during the exercise. We were then going to attach the correct resistance to the bike, which is acquired by weighing and measuring the person's height. We would then begin the exercise. With our method, we took the breathing rate every 2 minutes, but on every odd number. For example, we took it at 1 minute, 3 minutes, 5 minutes, etc. With heart rate, we took it every 2 minutes. So 2, 4, 6, 8, etc. With O2 saturation, we took it every 4 minutes. So 4, 8, 12, 16. Blood lactate levels were taken at 2 minutes, 5 minutes, 10 minutes, 15 minutes, and 20 minutes. RPE was taken every 5 minutes, 5, 10, 15, etc. Cardiovascular system analysis. Normative data suggests that the heart rate will steadily increase. It will then plateau after a few minutes and then gradually decrease post-exercise. With our results, there is an average decrease of 8 beats per minute from 1 to 2 minutes. This could be due to Rachel's heart rate decreasing at the start of her exercise. The readings could have been incorrect due to the equipment not working, so her heart rate may not have dropped as significantly. During 3 to 20 minutes, there was an average increase of 45 beats per minute. This increase is due to the receptors in the body detecting a change. The proprioceptors will detect when the body begins to exercise. The baroreceptors will detect that there's been an increase in blood pressure due to the exercise. The chemoreceptors will detect an increase in chemicals such as oxygen and carbon dioxide in the blood. They will send an impulse to the cardiac control center in the medulla oblongata, then send an impulse down the sympathetic nervous system to stimulate the SA node. This causes the heart to beat quicker, therefore causing an increase in heart rate. This increase suggests that none of them have reached their target zone. For example, at 20 minutes, Rachel's heart rate was 190 beats per minute. This would suggest that she was working in the anaerobic training zone. However, all her other results don't support this. Rachel's breathing rate remains under 20 breaths per minute, and according to normative data, the average breathing rate at rest for an adult is 12 to 20. This could suggest that she wasn't working anaerobically. Also, her blood lactase levels decrease, which would suggest she is working aerobically, as the oxygen consumed would be used to remove the lactic acid. However, at the 17th minute to the 19th minute, Luke's heart rate plateaus, suggesting he's reached steady state, as the receptors will no longer be detecting an increase in oxygen in the blood, so the chemoreceptors won't send an impulse to the sympathetic nervous system to stimulate the SA node, which will increase the heart rate. Our respiratory system analysis. Normal breathing rate at rest is 12 to 20 breaths per minute. Normative data suggests that breathing rate will increase gradually, then plateau, and it will eventually decrease after the exercise is finished. From the start of exercise to 5 minutes, there was an average increase of 28 breaths per minute across all of our data. This increase is due to the chemoreceptors detecting the increased levels of CO2 at the start of exercise. The chemoreceptors will send an impulse to the respiratory control center in the medulla oblongata. This will send an impulse down the intercostal nerve, which causes the external intercostal muscles and the diaphragm to contract, causing an increase in breathing rate. This increase is due to the muscles as they begin to exercise. They will have a higher demand for oxygen as they need it for respiration. From 10 to 18 minutes, there was an average decrease of 3 breaths per minute. This could suggest the breathing rate is plateauing, as the body is able to keep up with the demands from the muscles. However, Billy's breathing rate was the anomaly, because it was considerably higher than the others. His highest result was 63 breaths per minute, which suggests that he's working in the wrong training zone. Or the data could have been collected inaccurately, as the person counting the breaths may have done it wrong. Luke's breathing rate increases at a constant rate from 5 to 15 minutes. The increase is of 4 breaths per minute. It then plateaus from 15 to 18 minutes, which suggests he's reached steady state. This means that the chemoreceptors won't be detecting any more oxygen in the blood, as the muscles are being supplied with enough oxygen. Therefore, the breathing rate remains at a constant level. Energy system analysis. There are 2 pieces of data that we have collected that we can use to see which energy systems they were working in. The first is O2 saturation. From 4 to 8 minutes, there was an average increase of 8%. This suggests that more blood with oxygen in is being pumped around the body, so the muscles are therefore receiving more oxygen and becoming more saturated, which is suggesting that they are working aerobically, as they are able to breathe in more oxygen, which is getting to the muscles. From 8 to 20 minutes, there is another increase. This further supports that they are working aerobically. The second piece of data that we can use is the blood lactase levels. From the start of exercise to 10 minutes, there was an average increase of 14. At rest, blood lactate levels are around 0.5 to 1.5. This suggests that lactic acid was being produced at this time. At 10 minutes, Billy's blood lactate levels were higher than the others, as his were over 20. This could suggest he's working anaerobically, whereas Rachel's and Luke's, whose blood lactate levels were lower, as they were both under 20, could have suggested that Billy was working anaerobically, whereas the other two were working aerobically.